So a ball of mass 0.3 kilogram, a small ball, strikes a stationary ball of mass 0.8 kg. So let's say this is the second ball, which is of 0.8 kg, and the small ball is of 0.3 kg, and after hitting it is deflected through 90 degree. So in one of the horizontal vertical directions it goes, let's say it goes in that direction 90 degree, and its velocity becomes 1 meter per second. So after collision it goes in that direction and velocity is now 1 meter per second. Initially it was 2 meter per second. After the collision it is 1 meter per second. Mass of course remains the same. So this is the scenario. This one first coming, hitting this one, the bigger ball, and then it goes in the vertical direction, so just 90 degree with the previous direction. So we want to find the velocity of the second ball after the collision, the bigger ball. And in order to do that, what we will do, the second ball most likely will have an angle. We don't know yet, but we will have to calculate that. So we will try to find the total momentum. That is, we will apply conservation of momentum in the horizontal direction as well as in the vertical direction, in both direction, and this way we will try to find the components of the velocity of the second ball's velocity. So initially if we consider the horizontal direction, let's say in the direction of the initial direction, basically the direction at which the first ball hits the second ball. So velocity, the momentum is of the first ball, the total momentum is 0.3 times 2. This is the momentum of the first ball, and the momentum of the second ball is 0.8 times 0, since this is stationary. And after the collision we don't know the velocity of that, but we know the second ball's velocity becomes 1 meter per second, but it is in the vertical direction, so that the component in that direction is cos 90 degree. And plus, if we say the velocity, the horizontal velocity is vh, let's say, of the second ball, vh times 0.8, I can't write it here anymore, 0.8. So this component is 0, this is also 0 because cos 90 is 0, so it is 0.3 times 2 is equal to 0.8 times VH horizontal. So we get VH as 0.75 meter per second. Now we will consider the velocities, the momentum. We will apply conservation of momentum in the vertical direction, or in the direction perpendicular to the original direction, basically. So again here, before the collision, the momentum, the first object, the second ball is stationary anyway, so that will be 0.8 times 0, but the first ball, there is no component in that direction, so that is actually, we can write it like that, 0.3 times 2 cos 90 degree. That means this whole part, they are 0. We can directly write 0 though. So this is the momentum in the vertical direction before the collision. After the collision, this will be 0.8 times v vertical, we can say, plus 0.3 times 1. So this is 0, 0.8 times v vertical plus 0.3 times 1. So we get v vertical to be minus 0.375. So the velocity, the components of the velocity of the second ball, since that was minus and we were considering in this direction, we were assuming that the first ball went in that direction. So basically what is happening, the second ball's vertical component is in the other direction, that's why it's negative. So let's say this one is v, which is 0.375 in that direction, and in this direction the second ball's component is velocity component is 0.75. So we can find the v, the velocity of the second ball after the collision, as this 0.75 square plus 0.375, we can write negative square, so that becomes 0.84 meter per second, and the angle is theta will be tan inverse, which we will do away with the negative sign because we know which direction it will be. So 0.375 over 0.75, that will be, so theta becomes 27 degree. So when we look at the diagram, this is almost there, 27 degree, because if this component is in this direction and this is in this direction, the angle is of course this one. And if we consider the negative sign here, this negative sign, we could write the negative sign here, and that would give us a negative 27 degree, which makes sense because this is a clockwise rotation, so that's negative angle. So yeah, that's the direction and magnitude of the velocity of the second ball.